Alright, so let's look at some angle relationships. The first one we're going to talk about is when you have tangents and secants with a circle. So it says if a tangent and a secant, or chord, intersect on a circle at the point of tangency, then the measure of the angle formed is half the measure of the intercepted arc. Okay, so again, notice this is like our inscribed angles where the vertex is on the circle. Here's our secant, and here is the tangent. So when two lines come and or rays intersect on the circle, the angle that is formed is half of this arc they create. Okay, so notice it starts kind of at the vertex and goes up to that side. So once again, our property holds that when you have vertex on the circle, the angle is equal to 1/2 of the arc. Okay. Let's do some examples. First, we're asked to find the measure of angle BCD. So where is angle BCD? Well, it's from B, at C is our vertex, and out to D. What is the measure of the angle BCD? Well, notice it's an angle with a vertex on the circle. So it should be half of this arc that's inside of it from B to C. The arc is 142. So again, we set up our property. The property here says that we have an angle with a vertex on the circle, so the angle is equal to half of the arc. In this case, our arc is 142. Okay, so our angle is equal to half of 142. We go 142 divided by 2 is 71. Okay, next let's find the measure of arc ABC. So the arc from A through B, we start at A, go through B, and clear down to C. What is the measure of that arc going to be? Well, notice that here we have our other angle, okay, the full angle, and it's a right angle or a 90-degree angle. Okay, so its arc is ABC. So maybe you've deduced just by looking at that what the measure of the arc is, or we can use this property where our angle is equal to half of the arc. In this case, we know the angle is 90 degrees. That's half of our arc ABC. We want to find ABC, so to get rid of the half, we would multiply by 2. Okay, so the other direction, the arc is 2 times the angle, so we have 2 times 90, or 180. Okay, so we can go either way. If you need the angle, you divide the arc in half. If you need the arc, you multiply the angle by 2. Alright, so taking a look at this example, let's go through it. Here we have our diagram down here at the bottom, and we're asked to find the measure of arc RS. So where is arc RS? Now remember, the arc is on the curve of the circle, starting at R, following the curve until you get to S. This is the arc we're trying to find the measure of. Now notice we do right there have an angle with its vertex on the circle, and it happens to be the angle that cuts out that arc. The arc starts here at this edge of the angle and ends here at its vertex. Our property for when the vertex is on the circle is that the angle is equal to half of the arc. Let's put in what we know. We know the angle is 83 degrees. That should be half of arc RS. Let's find RS. Well, to get rid of the 1/2, we would multiply by 2 both sides. So RS is 2 times 83, or 166. Right? Find the measure of angle STU. Okay, so you start at S, down to T, out to U. This is an angle, so it means we're going along the lines here. Our vertex will be wherever the middle letter in the name is. So here's our vertex right here for our angle. Notice it's on the circle. We're trying to find the measure of that angle. We can see that we know the arc created by that angle starts at S and ends at T, and its measure is 154. Again, we have an angle with vertex on the circle, so we can use our property that the angle is equal to 1/2 of the arc. Okay, so this case we're trying to find the angle. It should be equal to 1/2 of the arc, and we know the arc is 154 degrees. So if we just take 154 and divide it by 2, we will have the measure of our angle. The measure of our angle comes out to be 77 degrees. So angle STU is 77 degrees. Put on those measures I've found so far. Finally, we want the measure of arc TSR. Okay, so let's take an arc. That arc means to go along the edge of the circle. So you start at T, going towards S to get to R. So we start at T, we pass by S, on our way to R. What would the measure of that arc be? Well, notice it's made up of our first arc from S to T, which was 154, and our second portion from S to R, which was 166. So for arc TSR, we can just add those two together. So it's going to be 154 plus 166. The measure of that arc is 320 degrees.